Hello, I'm Eugene, and today I'll be going over 12106 of Relay 4-3 because, it's going to be a big problem. First things first, read the instructions. Let T equals Tn YWR. Let K be the number of edges a floor root T dimensional cube has. Recall that floor X represents the floor function. Find the remainder when K plus 5 is divided by 100. First things first is that floor is basically your round down thing. So floor of 2.4 is going to be 2. Floor of 9.8 is going to be 9. You basically get the idea. So you basically take the value of t, take the square root, and round down to the nearest integer. And basically that's your result. In fact, shouldn't be that bad. I can even make a table just for better organization. So 1, 2, 3 is going to be 1, 4 to 8 is going to be 2, 9 to 15 is going to be 3, and you get the idea. Oh, and since t is only going to be a 2-digit integer, we don't have to worry about t goes to 100, going to beyond 100. So yeah, first that part's that bad. Then you get your output and then find out the dimensions. The 3D case isn't that bad, since I'm pretty sure everyone has heard about 3D cube, and I'm pretty sure finding the number of edges is like one of your basic math facts that you should know by now. In that case, a 3D cube is going to have 12 edges. 2D cubes are like something a bit unfamiliar, but I'm pretty sure many of you have heard of 2D before, like 2D animation or like 2D surfaces, which is basically just like a wall or something, like the palm of my hand or something. In this case, like a 2D cube would probably be a square, and that's going to have 4 edges. 1D figures are just going to be like based on length. So 1D is just going to have 1 edge, and points have no concept of like length, so 0 edges for points. So that's like the bit of the easier stuff. Now the trickier part comes with going 4D and up. I'm pretty sure some of you may have heard about 4D with tesseracts, like from A Wrinkle in Time or something, or if you've heard about space-time before, maybe that could be familiar for some of you. But 5D and up, like barely anyone has even heard about this thing. And so how on earth are you even supposed to solve this problem? I mean, I'm not sure if any of you have even heard about a 6D or 7D cube before. More importantly, how on earth did Mathly think it's a fair game for solvers to be able to work this through? I heard like some people say that they should be able to solve it with quote unquote common sense, but how exactly are you even supposed to do this if we never even heard about an 8D cube? Huh. Probably gonna have to like step back and think for a second. Maybe we'll see if there's like anything going on with the 0 to 3D cubes and see if we can like find a way to like at least reasonably get higher up. Maybe I'll start by considering vertices first. A vertex. A 0D, it's just a point. That's going to be 1. 1D, that's like an edge. That's going to be 2. A square has 4 vertices. A cube has 8. Hey, this looks like powers of 2. So so we can say that an n-dimensional cube is most likely going to have 2 to the power of n of vertices. But that's vertices. We're looking for edges. And it's going to be a bit tricky to find. Let's see if there's like anything I can look at in this thing. So 0 doesn't have anything connected. 1D, like there's this one connection. 2D, there's like 2 connections, but like not all the vertices are connected to 1 point, but each vertices is only connected by 2 edges. In 3D, 3 edges. Wait a minute. So in a cube with n dimensions, like each vertex is connected by exactly n edges. And I think we could safely assume that this pattern is going to hold up in the higher dimensionals too. So if we have like 2 to the power of n vertices, and each vertices has as n edges. But at the same time, this has an edge with this is you're going to overcount this to this vertices. So you're going to have to cut by 1/2, and as a result, you're going to get n times 2 to the power of n minus 1. All right, so 40 cube tesseract is going to have 16 vertices and 4 times 2 to the cube, which is going to be 32 edges. And you can plug in the value of n to get the number to get the edges. I got something from a friend. So turns out the t that I got would, and from the t that I got, the floor of the square root of t is going to result in 8. Good thing we already talked about the multi-dimensional cubes and stuff. So in the case of an 8D cube, we're going to have 8 times 2 to the 7, which is going to equal 1,024 edges. That's a lot. And so we get k equals 1,024, and k plus 5 divided by 100, the remainder is going to be 29. Whew, that's a big problem.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.